What's up, everybody? This is Matt Brown with another IoT hacking video. Today, we're going to allow AI to hack this video camera, and it is going to discover a never-before-seen vulnerability in a proprietary binary protocol. And it's going to do it with a tool set that I've been working on for months and am now open sourcing to you, the community. And if all of that is interesting to you, you should subscribe to this YouTube channel, smash that sub button, and I appreciate it. But let's get over to the desk and connect up our camera to our test equipment. So we have our UART adapter here that we're going to plug in. So we've done some hardware hacking on this camera in previous videos. Definitely go check those out. And we found the UART interface on it. So what I've done is I've just gone and soldered up these three wires to allow us to interact with this device. And so now I'm going to plug in 1, 2, 3, the ground, the TX, and the RX right there. Zoom, autofocus. There you go. There's our interface with those three wires connected. And then I'm going to go ahead and we got it powered off, and we're just going to plug in the Ethernet and our power. And now we're all rigged up. So what's cool about what we're going to do today is we're going to give our LLM access to this physical debug port by allowing it to do tool calling to this USB interface. Let's take a look over here at how we're going to do that. So normally when we're doing IoT hacking, we would use a terminal emulator here like Picocom, and we'd probably set the baud rate to be like the standard baud rate here, and we can interact with the device over this terminal. I'm going to go ahead and power it on, and we're going to observe the output that comes here, and we can interact. This is a somewhat interactive session, but today for our exploit, the real value is going to come just from monitoring the output, right? Because a lot of important programs, standard error and standard out, gets piped to this UART interface, which is going to allow us to give that to Claude through tool calling and allow it to use the standard out to debug its exploit. So let's look at the protocol though that we're going to that we're kind of investigating today. So I've also done some hardware hacking on this device, and I have got a root shell already set up on it. Now, before you guys freak out and be like, oh, you already have root, and then you're exploiting it because you have root. So this is a common process in vulnerability research where you want to get as much access to a device as you can to create an exploit that can be exploited over the network, right? So we are discovering a flaw which could then be used against another camera without physical access to it. All right, so we're gonna go ahead and we're going to telnet into the device, and it's waited. We gotta wait a little bit. Gotta wait a little bit, guys. All right, unless it is not liking, it's trying to get an IP address. All right, we're gonna let it get an IP, and did it get it? Did it get it? Did it get it? It did. All right, sweet. So now it's got an IP address, and we can see that I've got this telnet session set up where I just get a root shell, and let's go ahead and let's look at what processes are running on this device. And there is one process in particular that is the most important, and it's this UMMP program. This appears to be where all custom, closed source, non-open source business logic lives, is inside of this binary. And what we can do is then we can run netstat to see what ports that it is listening on. So in previous videos, we attacked the RTSP service, which is port 554. And we found that we could stream video from the device without authentication. We found that we could interact with a lot of ONVIF web services using like the ONVIF SOAP XML protocols over port 8080. But there is this other port, 8025, that is interesting. So that also, you can see, is being opened, that socket is being opened and listened on by this UMMP binary. So this is the service port for the custom binary protocol. And let's go ahead and let's look at what we can see if we just try to connect on that port. And what we're going to do is, if I can type, we're going to connect on port 8025, and then I'm going to pipe the output to a hex editor, right? And so what we're going to see is we see in our UART interface, we can see right here that, that we got some output from that UMMP program, right? That's really important. But we also got a response from the server. We got some binary data, right? It's not like text, right? If this was like an HTTP server or something else like that, we would send a request and get like a valid text-based response, right? But this is a custom binary protocol. And so we don't have any existing tooling to go after this, but this is all very interesting. Okay, so we're gonna hop out of PicoCom here, and then I'm gonna close that socket that I had open. So what I've also done is I've loaded that UMMP binary into Binary Ninja, and I have found some functions in here that I think are all the critical functions for reverse engineering this binary protocol. And when I was first doing this, Claude actually prompted me to kind of give it this decompilation. So what I have is I've got a number of these important functions here sitting in a directory that we're going to talk about in a minute when I show you the prompt that we're going to give to Claude Code. And so here we can see, though, there's a bunch of messages that says, okay, parse the Huayi CMS message. So that Huayi CMS seems to be the name internally within the binary that it uses to call. That's what this binary protocol is called. It's you know, we can shorten it to the CMS protocol, or sometimes down here it's kind of like all these messages are prefixed with HY, so the high protocol or whatever you want to call it. But this is clearly all related to the custom protocol. So there are like sub functions here that get called. So like here, authentication potentially is what's being dealt with in this function. So a lot of this function, decompiled source code, has been given, has been put in a directory, and we're going to give it to Claude. But there's more. So we're going to give a lot of context to Claude. Let's go ahead and actually start to look at the prompt that we're going to give. I'm not going to read this whole prompt to you. Basically, I tell it like, hey, read your skills. That's a good segue to show you this. This is the repository that I'm open sourcing. This is open source right now, IoT Hackbot. I've been working for months on developing kind of a framework for giving Claude Code more and more context and more tool calling ability to interact physically or over the network with IoT devices. And so here we've got a number of skills that are defined in here. And so one of them is the telnet shell skill. That's going to allow it to telnet into the device and interact on the shell to do some debugging and stuff like that. There's also PicoCom that's going to allow it to get the standard out messages. And so those are all what are in our prompt here. So I tell it like, hey, remember to read your skills. I'm gonna gloss over this prompt. You guys can read it later. But I'm saying, hey, like I'm pen testing this IoT camera. There's this binary UMMP. Like I want to target the protocol that's running on port 8025. And hey, this device is online at this IP address. And then I tell it, hey, you got a telnet shell on port 2222. You can log in and interact with it with the telnet skill. And I also, in the previous video, we unpacked, we like took the chip, the firmware chip off of the device, and we dumped all that firmware. Well, I'm going to say, hey, have at it. Here's a directory with all of the firmware if you want to statically analyze it. So, and then right here in this directory, I say, hey, I dumped a bunch of functions. You can kind of do like this ls. So there's like 7 different functions that I dumped into these text files so that it has context on those. And then I said, hey, that you've also got this UART interface where you can get the standard error and the standard out from the service. Also, I said, hey, like you want to use this directory, this work in progress directory for all of your scripts and stuff like that. You'll see that this is empty except for the prompt that we're reading right now. And I say, hey, you should reverse engineer this binary protocol and discover if there are any security flaws in it. And then I tell it to stop and prompt me if the protocol becomes unresponsive, which it can do sometimes when you're aggressively testing it. So without further ado, I'm going to take that prompt. I'm going to copy it. I've got it like over in my other screen also. It's just easier to copy. All right. So we're going to, in the IoT Hackbot directory here. So this is just that. This is the open source repository now with all my tooling in it. There are some other tools that I will be adding to this as I polish them up. So I've got other stuff to come. So running SuperClaude, which is just an alias for Claude with this bypass permissions on. And we're going to paste our prompts, and we're going to go. We're going to launch it. So we can do a lot of monitoring of what's going on the UART shell, and we can also watch over the network. So that's what I want to do. I want to say tcp.port equals 8025, and then let's run a new capture here so we can see in real time what Claude is doing. All right, so it's got a plan. It's going to start monitoring the UART interface. That's good. And then it's going to examine some decompiled functions. Awesome. It's going to explore the firmware extraction to locate, the binary and configs. That's great. It's going to connect it to the telnet shell and gather device information. It's going to perform network reconnaissance. It's going to analyze the protocol, and then it's going to, do some other stuff. So here we go. It's reading in. We're reading in all of that decompiled, those decompiled functions that are critical. So yeah, while we're doing that. So the decompiled functions, while we watch this, we can talk about my kind of future trajectory for this tooling and things that I can improve, right? So there's obviously Ghidra MCP libraries out there. There's definitely some ones for IDA. I really hope there's some ones for Binary Ninja where you can let the LLM just dynamically make certain API calls into your reverse engineering tool set. And so that would be a lot cleaner way and a lot more of a kind of organic way to let it find the functions that it needs to give it the context. Okay, so it says, excellent. I now have a good understanding of the protocol structure, right? Like I just dumped it those functions and it's like, oh yeah, I know how to speak this protocol now. All right, let's go down. It's running some Python stuff. All right, so it's running netstat just to observe that it is listening on that port. Okay, so now it's using the telnet shell just to kind of enumerate some of what's going on. Awesome. It's interesting. It kind of skipped over the firmware extraction. It might not need that. I don't even think it necessarily needs the static firmware. Why is my screen doing that? All right, we're gonna full screen this for a minute to get it to not do that. There we go. Okay, it's interesting. It's running Nmap. Sometimes it runs Nmap and sometimes it doesn't. I don't think it really needs to do that in this case. So that's kind of fun. Let's try to scroll up and see what it's done so far. Okay, yeah. So it was just enumerating. It was using telnet. I'm going to click off and I'm going to talk a little bit more about this tool and what makes it tick, okay, while that's running in the background. So obviously we've got these skills here. I do have some other skills that I've integrated into this project. Those are the WS Discovery and the ONVIF Scan. I used those in a previous video and I open sourced those in a separate repository, but now I'm going to maintain them purely as a part of this IoT Hackbot project. And what these do is they very much have the ability to probably one-shot the vuln that we found last time. So this just gives it the skill to run WS Discovery, which allows you to discover if an ONVIF, if like a device is ONVIF compliant, and to know the URL for where to make ONVIF requests. And then you pass that URL to ONVIF scan, and then it can run authentication testing to see if all the ONVIF calls are properly requiring authentication, which we found on this device that like none of them are. So let's go back and see where we're at. Okay, oh cool, it's already building a Python tool to do the Huawei CMS protocol testing tool. All right, awesome. Let's see if it's sent any packets. Ooh, it's okay, so it's already sent some data over the network in some of these Python scripts that it's writing. So let's just go and look at the packets. Whoa, oh wow, a lot more. There's a lot more. Let's see if it got back any interesting data so far. All right, so it's doing some development of its tooling. That's good. So what I do know about this protocol is that it has some like flawed session management, and basically you can make like a total of 10 connections, and then I'm pretty sure you have to power cycle the device to get it to work again. So sometimes when it's doing its exploit dev, it will use up all of those sessions, and then it will require my manual intervention. So hopefully it stops and tells me to power cycle the device according to the prompt. So, all right, gonna craft and test protocol packets. All right. Yeah, we can see so far. I don't see any. I'm looking for text data to show up in some of the response packets. Okay, this is like the initial like authentication packet. Oh, okay, I'm pretty sure it like found the vuln right here. Now, does it know that it found the vuln? Does it know that this is actually a vulnerability? So the final vuln is authentication bypass. You can execute all of these different commands, which actually, let's go ahead and look at that in Binja. So let's go back here so right here, you see a bunch of these like sub functions or whatever, these sub commands that can be called within the binary protocol. And so it's just this case statement on 2, 4, 5, whatever. So like 6 here is get network config. So it dumps a bunch of like network configuration data back. Now, some of these functions, you'd be like, oh, cool, I'd love to set the device config, but it's just stubbed out. They didn't actually implement the function. It just returns 0. So there's a bunch of these functions here where it's just like return 0, return 0, return 0. And so those functions are not implemented for this device, or maybe they never were for any devices. Who knows? But there are other commands that are implemented. And so let's go back to our testing. All right. What do you got for me? Excellent. The protocol worked perfectly. We've successfully demonstrated multiple critical vulnerabilities. Let me check the UART debug output. All right. This is good. This is good. Yeah. All right. So it's writing into a vulnerability report. That's fun. Let's go look at that. Alrighty. Okay, Claude can get really dramatic when it's like talking about the critical nature. This is one of the worst authentication implementations I've seen in IoT devices. Oh, really, Claude? Tell me how you really feel. All right. All right. Well, which you can actually show me like the real stuff. Okay, he always wants to give recommendations also. Okay, so scenario 1, yeah. Okay, send device. Okay, so these are 2 of these commands that you can execute, and you can disclose information about the device. Oh my gosh! Stop the physical UART attack stuff. Oh, interesting. So it's talking about like different commands that don't require authentication. Okay, I think all those are actually legitimately implemented. I don't know if it understood that or not. But let's actually, oh, I forgot. Yeah, we can like look to see. Aha! Here we go. Here we go. It definitely did find it because we can see over the network that it sent this packet right here, okay? And I believe, so I believe this byte right here, see the 04, that corresponds, let's go over to Binja, to this case statement. So 4 right here is the get device config command. And so we can see right here that after it sends this message with a 4 byte here, we get back the device network configuration, which, by the way, includes some passwords that this device just doesn't happen to have set. And so there are some like DDNS passwords. That's what these fields are down here. And so if those usernames and passwords were set on the device for those protocols, they would be disclosed right here. So that's fun. All right, here it is. Elapsed time. It definitely didn't take you an hour. All right, 4 criticals. Again, it's really dramatic in its like report writing, but in reality, we have found one authentication bypass vuln, and it's fully reverse engineered. You know, the header, like this 88-byte header structure, the variable payload protocol structure, and so. There we go. There we go. It did it. It's just crazy. Like it's able to look at the code and all of this context, right, that we're providing to the LLM to allow it to discover like an unknown vuln like this that crafts a packet, you know, perfectly like this, and then gets this response. That's just incredible. So now, as extra credit, I want to try out one more thing. I'm feeling lucky. All right, so we're gonna start a brand new session. Actually, let's like go back and let's go work in progress 2. Okay, right here we're gonna say this is your working directory. Use your skills. Wasn't planning on doing this. Find. All right. Use your skills. Use this working dir. Use WS discovery and ONVIF scan to discover vulns in the camera at if the PTZ service doesn't require auth, write a script to move the camera. All right, let's see if we can do this. And I'm gonna get ready by viewing the video feed. All right. So while this is going on, we will view the live video feed, and then we're going to bring this over here. All right. Sweet. So yeah, so it really knows how to use these tools correctly, right? Okay, perfect. The camera has been discovered. Yeah, it's gonna get this. Yeah, right. This path, right? This URL path, right? It needs to know what port the ONVIF service is running on, and then the URL path, right? And it got that with the first tool, and then excellent. The scan found 25 vulnerabilities. The camera has completely unauthenticated access to critical device services, including the Pantel Zoom. Nice. All right. So now it's gonna write a script to move my camera. All right. Perfect. And obviously it can do a bunch of other stuff without authentication. We talked about that in the last video, but now I want to wrap this all together with the new tool set, the IoT Hackbot toolset. So, okay, cool. Now it's creating a script to move the camera. All right. All right, so we're running. It's running the script. I don't know which direction it's going to try to move it. All right, PTZ control. No, you didn't move it. No, write a script. I want you to move the camera up. All right, so it's going to pass the panel zoom. The camera has moved up successfully. Are you broken? Okay, that was moving. That was not the panel zoom. Down. It's not working. What's going on? No, it's not. It's not moving. Try to move lots of different directions. Oh, there we go. Nice. It worked. We got it to move. I can't have it looking in all directions here. Wow. Here, let's watch it. Oh gosh. There we go. All right, so as you can see, we are able to move our camera around with AI. So does this mean that Skynet is coming? I don't know, but this has been fun. My next steps, like I said, are to start integrating MCP to give it better, reverse engineering workflows, and just to see where this takes where this takes me next. So thank you for watching this video. Definitely subscribe if this was interesting to you. If not, leave an angry comment. Have a good day.